Good morning, sir. Good morning, sir.
Good morning. Wait for a while. Okay. I hope the screen is visible to all.
Yes, sir. Right.
Right. So we will start the discussion part, and let us take up new numerical related to equilibrium. In this numerical, a rod is given, a rigid rod is mentioned, and this rigid rod is hinged at this location. Moreover, it is connected with the help of this flexible, you can say flexible rope. And it is hinged at this location. Right? This is given. This angle is 70 degree. This is given. This is point B. This is point C. Point A. This the complete system is held in position with respect to this force or this load, whose magnitude is capital P. The distances mentioned are from A to B, this is 100 mm. From B to C, it is 250 mm. 250 mm. This distance, that is this perpendicular distance, you can say, this is given as 250 mm. So in this numerical, knowing that the magnitude of this vertical force to be 400 Newton. So this is again given that this force P is of 400 Newton magnitude. Determine the tension in cable CD. This is point B. You are supposed to identify first of all the tension in this member CD and reaction at point B. RB, this is what you are supposed to identify, and tension in member CD or DC, whatever it may be. That means it is understood that with the help of this force, this rope or this cable will undergo tension force, or it will have a tension force associated to it. So definitely, let me consider this force to be TCD, not TS. TCD, tension in the force, tension in the member CD, right? So you are supposed to draw the free body diagram associated to this. So let us draw the FBD. This is load 400 Newton. This is point A, right? At point B, it is a hinge. So hinge will develop two reaction forces. Let me assume the direction of these two forces to be in this manner initially. So let me consider this to be RBV and let this to be RBH. Okay? Then this is another part, which is tension in member CD. So this forms our free body diagram, and in this, what information is given? This angle. This is of 70 degree. Okay. What you do is, in order to solve this particular numerical, this will completely depend on the geometry. We should have the angle values, because if you see, this is an inclined force. This inclined force has to be resolved into components, isn't it? So this will be, you can say, uh, this you can call it as RCD sine of, let me consider this value to be alpha. Okay. Sine of alpha, and this will be cos of alpha. So you are supposed to identify that alpha value. Can you find it out?
So 55 degree.
How much?
55 degree.
55 degree. Okay. So how did you identify this angle?
So it is isolated triangle, opposite angle.
Great. So 55 degree comes out to be the answer. That is correct. And with the help of this 55 degree, you can then resolve this into components. This will be cos alpha. You substitute the proper value. Then we know that the complete system is in equilibrium. Once we say that this system is in equilibrium, then you are supposed to use equations of equilibrium to identify the unknown parameters. Now, if this complete angle is of 55 degree, and if I want to make use of equations of equilibrium, so step by step, I will jot down all the values. How many forces are there in the x direction? RBH, which will be in the positive. This is what I have assumed initially. Minus TCD cos of 55 degree equal to 0. Then, yes.
So the complete angle BC is 55, but the angle which we have to consider will not.
That's why I'm solving it step by step, so that we will come to know what are the other essential parameters or angles that may be required. Okay.
So 55 main.
Yes.
55 main angle.
Why?
So 55 is the complete angle. This is not the angle with x-axis.
Okay. So you mean to right. Fine. Yes. Correct. Fine. So this is the value of complete angle you have told me, and right, when you resolve it, in that case this angle is required. Very true. So what should be this angle? So what I will do in order to find out this angle with respect to this horizontal axis, I will drop a perpendicular.
20 degrees.
If I drop this perpendicular over here, you know this complete dimension. You also know this dimension. This is 250 mm. And with the help of that geometry and the information related to this thing is available, how much this angle, small angle, comes out to be?
20 degrees.
20 degree. Okay, this is 20 degree. And balance जो है that will be now 35 degree. ठीक है. And hence alpha comes out to be 55. Right. So if this is 20 degree, so now can I substitute this 20 degree over here? Now it is okay. ठीक है. Next. Summation of forces in y direction equal to 0. So how many forces do you see? One is minus 400, then plus RBV minus TCD sine of 20. Anything else? No. Equated to 0. So over here, what do you find? There are three unknowns: RBH, RBV, and TCD. So we will require one more equation. So you take moment. About what point would you like to take moment?
So B.
ठीक है. Moment about B equal to 0. So with the help of this, what exactly you are doing? You are eliminating these two reaction forces initially, and you will come to know one unknown parameter, that is of TCD. So you formulate the equation. कितना रहेगा? So if I say 400, what is the perpendicular distance associated to 400? For that, you will require this distance. Am I right? That is from this point to this point. Is it okay? So how much this should be? So see, you have already evaluated this 20 degree. This will again be 20 degree. Do you agree? This angle?
Yes, sir.
Okay. So if this is 20 degree, you can certainly find out this distance. How much it would be? 100 of
So 100 cos 20.
100 cos 20. Exactly. 100 cos 20. In which direction it is rotating about point B?
Clockwise.
Anti-clockwise, okay?
Yes, sir.
Anti-clockwise. Similarly, uh, here at point C, there are two components, right? One is of cos and another is sine. So please let me know what will be the values associated to, let's say, TCD cos of alpha into what should be the perpendicular distance. So in order to avoid confusion, what you can do is,
250 cos 20, sir.
yes, correct. So in order to avoid that confusion, what you can do is, you can relocate the position of these components over here, like this. Okay. So this is your TCD cos of 20. This is TCD sine of 20. Okay. So TCD cos 20. What value did you tell me right now? This will be the perpendicular distance.
Yes, sir.
So what it should be? Cos or sine?
250 sin 20.
Right. 250 sine 20 degrees, and this will rotate about point B in the clockwise direction. Then plus TCD sine 20 into what should be the this value? 250 sine 20.
250 cos 20.
Sorry, cos 20. Clockwise रहेगा, anti-clockwise रहेगा. Again, it will be clockwise.
Clockwise.
Equate it to 0, and now find out TCD value. Tension in the member CD. How much do we get?
So 233.9.
Acha, 233? No. 233. 1 minute, hold on. See, this was 20 degree. बराबर है? What we are doing? We are actually calculating this angle. क्या होगा वो? Are you getting me? What I am doing? So see, look here. There is a mistake. What mistake we did? We found out this 20 degree, but actually what we are doing? We are resolving this inclined force over here. Got it? So what will be the change? This angle. So over here it is 35 degrees, isn't it? So this won't be 20. This now will be 35 degree. Are you getting me? This is the mistake what we did. Okay. So we need to be careful when we consider the geometry part. Geometry में ऐसा होता है बहुत सारा. ठीक है. So how much this should be? 35. This is 35. Rest everything shall be same. कितना था? This won't be 20. This is 35. How much do we get? I am getting this value to be
183.54.
183.55, and once we get this value of TCD, you substitute in these two equations in order to calculate RBV and RBH. Once you get these two values, then you can identify the R and theta, because RBV and RBH, these are the components, and what is asked? Reaction at B. So a reaction at B will be under root of RBH square plus RBV square, and theta will be tan inverse of RBV, that is Fy Fx. Okay, is this okay? So we need to take care of the geometry part and solve it accordingly. Okay, is this okay? Fine. The next example. Such kind of examples you will come across in your geotechnical engineering. आप लोगों का अभी geotechnical engineering 1 शुरू है क्या?
No, sir.
Okay. Fine. I think in the 4th semester or so, you will be introduced with the geotechnical engineering. ये खत्म हो गया फिर.
Sir, इसके पहले वाले क्वेश्चन का आंसर क्या?
What you mean to ask about R value?
Yes, sir.
RB comes out to be 527.2. RB. RBX 150.4. RBV is 505.3. And theta is 73.43. Okay. Right.
Sir, वो नहीं आ रहा है वैसे.
You can verify it later on. we'll discuss this numerical. In case of any difficulty, we will discuss it later on. Okay. Seven two double zero Newton. This is 5 meter. This is 7 meter. Okay. These are points A and B. Right. So this is a weight. Whatever figure I have drawn, this is a weight, and the shape of this weight is trapezoidal. So it is a trapezoidal block of weight 7200 Newton acting as shown in figure. The ground reaction varies uniformly from an intensity of PA Newton per meter to PB Newton per meter. You are supposed to determine these PA and PB values.
So then explain the question again.
Yes. So see what is given, what is mentioned in this numerical. This weight, whose shape is trapezoidal, this is resting on the ground surface, and with the help of this weight, which is steady, equal and opposite reaction forces are developed within the ground. And how is the reaction? It is again trapezoidal one, and the intensity of these reaction forces are PA and PB, and they are varying uniformly. So this is an example of uniformly varying load, which we call it as UVL. Okay? These are the distances which are mentioned, and this being a trapezoidal load, the load which is acting, as you can see over here, this is based on the geometry. Okay, so 7200 Newton load is acting, intensity within the earth surface, it is developed in this manner, that is a uniformly varying load. You are supposed to identify PA and PB values. Again, the geometry will come into picture, and now you are supposed to find out or draw the free body diagram associated to this complete figure. Before that, you please concentrate on this uniformly varying load. And as far as uniformly distributed load was concerned, if you remember, we had solved this numerical wherein uniformly distributed load was mentioned, and the intensity of this uniformly distributed load was given, some magnitude was given. Let me consider this to be small w. Let me consider this distance to be L. And what we did, we have identified one concentrated load which will represent the complete effect of this uniformly distributed load, and which will be acting at the centroid of this area. Okay. So what it was nothing but the area of this shape. So what we found out, the intensity of this concentrated load, whose intensity was equal to area of shape, whatever shape it may be, right? And this complete intensity acts at the centroid. So you know what is centroid, right? For this shape, obviously this will be acting at L/2 distance. And what is the intensity? It is nothing but area. So here the intensity came out to be W into L, and the distance, this came out to be L/2. Similarly, we are supposed to identify the intensities, okay, with respect to this shape. Why I called intensities, because now you will come to know. If I separate what I will do is I will separate this uniformly varying load into two forms. Now you can see I will just drop a perpendicular over here, and what do you observe? That there are two different shapes. One is rectangular and another one is triangular. So once we obtain these shapes, what do you observe? This complete intensity, whatever is given, is PA, correct? This is PB. So if I want to identify this much distance, how much it should be?
PA minus PB.
PA minus PB. Okay? This becomes the intensity over here, and this will be PB all along. So if I want to find out the intensity associated to, let's say, this triangular portion, rectangular portion, what it should be, or what it will be?
PB.
Intensity shall be PB into, see what we are identifying, the area, as you can see over here, area of the shape. What is this complete distance? You are supposed to
12 meters.
see this figure, and over here it is 12 meter. And where it shall be acting? At the center, isn't it? Now, let's talk about this triangular portion. Okay. Over here again, we will be identifying the intensity of this triangular portion, area of the shape. क्या होगा इसका एरिया? Half base into height, and how much is the height? PA minus PB. Correct? So this becomes the intensity of that point load, and where this point load shall be acting. So if you remember,
2 by 2 is by 2.
I mean 1 by 3 of base or 2/3 of base. Okay. So if I say 1/3 of the base, where it shall be acting? From which point? From this point?
Yes, sir.
So somewhere here, right? So if I say 1/3 of base, which is 12 meter, this comes out to be 4 meter from point A, because this is point A, this is point B. Barabar hai? So somewhere here, correct? And what should be this? This is 6 meter for the rectangular portion, and this will now be 4 meter for your triangular portion. Okay. Now see, since the arrows are upwards, so intensity, whatever intensity we are identifying, that will be again upward, because you can see these arrows are facing in the upward direction. That's why whatever intensity we are identifying, that will again be in the upward direction. So over here, this will be in the upward direction. So have you understood whatever we have done? Okay, this is the intensity. Okay, and this comes out to be 6 times PA minus PB. And at what distance it is acting? At a distance of 4 meter from point A. If you want to identify the distance from point B, it will be 2/3 of base, that is 8 meter from B. One and the same thing. Okay. Once we have identified this concentrated loads, then we draw the free body diagram. Final FBD, you can say. Over here, what do you observe? One information already is given over here. That is, this weight of trapezoidal body is shown to be acting over here, which is at a distance of 5 meters from point A and 7 meters from point B. This is what is given. So what we have identified? We have identified the reaction forces in the form of point loads. Likewise. So this is 4 meter and this is 6 meter distance. What are the intensities? This is nothing but 6 times PA minus PB and this is how much? 12 times PB. Correct? What is balance? You are supposed to identify the reaction forces. That's it. Everything is in equilibrium. No horizontal forces, only forces in the y direction or vertical direction. So summation of forces in y direction equal to 0. How many forces are there? This is 7200. 6 times PA minus PB, which is positive, plus 12 PB minus 7200 equal to 0. So with the help of this equation, I cannot find out the unknown parameters. What else can you think of? You can
Moment about
take
0.
moment. Yes, at about what point? A. Let's say about point A. Right. So 6 times PA minus PB into perpendicular distance shall be 4 meter, and this is rotating in the anti-clockwise manner. Similarly, 12 PB rather into 6. This is rotating in the anti-clockwise direction. And one more component is of 7200, which will be rotating in the clockwise direction, perpendicular distance being 5 meter. These are two equations. Solve them and get the answer. Okay? So you can identify the value. I am getting these values of PA and PB to be 900 Newton per meter and 300 Newton per meter respectively. PA is 900
Yes, sir.
and PB is 300. Okay?
Yes, sir.
Okay. Next. Okay. Next, numerically write down a weight, capital W, rests on bar AB. Weight of capital W rests on bar AB. The cable connecting capital W and point capital B, cable connecting capital W, that is weight, and point B passes over frictionless pulleys. Passes over frictionless pulleys. If the weight of bar AB is negligible, show that reaction at point A is W into L minus A divided by L plus A. ये आपको prove करना है. This is what you are supposed to prove. So the figure associated to this is a bar AB, which is of negligible weight. This is hinge. This is point A. This is point B. And these are the frictionless pulleys like this and like this. This is that weight. And this is the distance, small a. This is capital L. So you can take this example as your homework or assignment. Okay, I will be declaring the assignment tomorrow. I will post everything on the classroom, and I will also declare the date on which you are supposed to submit the assignment number 1. Okay, so that assignment number 1 will include this numerical also. Okay, so since you are supposed to prove this, output actually is given to you. You are supposed to formulate the equations in such a way that the equations are in right order, so that this output is achieved, final output is achieved. So you need to be careful while drawing the free body diagram. You are also supposed to take care of the information which is given in the numerical or the problem statement. Okay? So you take this as your example, try to solve it. We will take up next example. Yes. Yes. No, because it is not hinged. I mean, this point B is not connected with any kind of support. But yes, it is connected with the help of this rope. So that's what you are supposed to identify. So आपको ये सब जानने से पहले you need to draw the free body diagram very carefully. That's what is the point. Okay. And remember, in your examination, one thing I would like to tell you, in examination, may it be test 1, test 2, or final end sem examination, and also the higher semesters, maximum marks are given to your free body diagram, maximum points are given to the approach. It may happen that by mistake you may consider some wrong value, as what we did in the earlier numerical. If you have noticed, we used 20 degree, but it was 35 degree. Those mistakes, for those mistakes, less deduction will be there. But if your approach is correct, your maximum marks you can score over there. If everything is correct, no one can dare to reduce marks. But even if you even if you feel that there is some sort of confusion related to the final answer, but if your steps, if your free body diagram, whatever you have shown, whatever you have represented, if it is correct, then you will score the maximum marks. 80% of marks you can score, right? although your final answer is wrong. So step marking, whatever we call it as, that is associated to your such kind of subjects or courses wherein you will find you are supposed to represent any rigid body or whatever numerical is given in the form of free body diagram. Is this understood? So try to approach the numerical in such a way that the free body diagram should be clear. Clear to you as well as for the examiner also. Okay? Fine. So
Thank you, sir.
let's take new example. Or should I stop? Should I stop over here or?
Will we have a class?
Okay, okay. So I will stop over here. We will discuss few more numerical in the next class. Okay?
Thank you, sir.
Okay, thank you. Thank you.
Thank you, sir.
हेलो सर
हाँ बोलो.
सर एक्चुअली मेरा जम्मू कैंपस में